Hi, in this video we're going to be talking about multiplying polynomials. You might be thinking to yourself, well, what about dividing polynomials? And actually, dividing polynomials is really tricky. In fact, you're probably not going to learn about dividing polynomials until you get to Algebra 2. Probably in 2 years from now. Maybe even not until you get to pre-calculus. It is a really kind of complicated idea. But multiplying polynomials is tricky enough. We'll focus on that here in this class, and you'll learn about dividing a little bit later. But for multiplying polynomials, and remember, a polynomial is anything that's not a monomial. So an example of multiplying polynomials would be x plus 9, which is a binomial, times x squared plus 3x plus 3, which is a trinomial. So whatever it is that you're multiplying together, that's the idea. And if you remember way back from the beginning of the year, the idea of distribution, if I ignored the x part, and if it was just 9 times x squared plus 3x plus 3, you know how to do that, the distributive property. You take 9, you multiply it by the x, the 3x, and the 3. That's all. That's all it is. When you have a polynomial, when you're multiplying two polynomials together, it's actually the exact same idea. You have x plus 9, this polynomial, it in fact works in exactly the same way. We're just going to break that apart and take each individual piece and distribute it. So I'm going to take the x and distribute that. And then I'll take the 9 and distribute it. So I'll write it out what I mean. I'm going to take the x and distribute it across x squared plus 3x plus 3. And then I'm going to take the 9 and distribute that across x squared plus 3x plus 3. This part of the problem, by the way, should look similar to some of the other questions on your problem set. Probably not exactly the same. You won't have necessarily the same exact polynomial in those parentheses. But really, it works the same way. Whatever you have to distribute, whatever's sitting outside of a set of parentheses, you distribute it. You multiply it to each of those individual terms. X times x squared is x cubed. X times 3x is 3x squared. X times 3 is 3x. Then I'll do the 9. 9 times x is 9x squared. 9 times 3x is 27x. And 9 times 3 is 27. Multiply out the individual pieces, and then combine like terms. I want to find like terms. X cubed, there's no x cubed to combine that with, so that's not going to change. 3x squared will combine with the 9x squared, so I get 12x squared. 3x combines with the 27x, so I get 30x. And then the 27 doesn't have anything to combine with either, so we have plus 27. And so x cubed plus 12x squared plus 30x plus 27, that will be my final answer. And this is also written in standard polynomial form. That was what we referred to in the previous video. The idea that the exponents are decreasing as we go through the polynomial. So just write your polynomials like that to get to make it look the best, essentially. It's not incorrect, again, to write it in a different order. It just looks weird. Any problem where you have two polynomials multiplied to each other, even if this was a trinomial, we just have 3 of these. Just take the individual pieces, the individual terms of one polynomial, and distribute it across the other. So the x gets multiplied to all of those. The 9 gets multiplied to all of those. And if there was a 5x squared in front of that, then you'd have the 5x squared, and you multiply it to all of those, and just combine like terms at the end. There's another type of problem that I want to talk about, though. There's a couple of problems like this, only 1 or 2 questions like this on your exercise. But something like this. X plus 7 to the power of 3. Or even x plus 7 to the power of 2. I'm sure you've seen problems like this in class. But really, this is not much any different. What you gotta know And I can't tell you how many times I've seen students make this mistake. This is not x cubed plus 7 cubed. This is not x squared plus 7 squared. No, no, no. Exponents do not distribute. That's an exponent, not a coefficient. If it's outside, then yes, as we just discussed, you do 3 times x and 3 times 7. That's fine. That's what the distributive property says. But this is not a coefficient. This is not distributing. We are not distributing that power. You might have talked about how you can kind of distribute the power when you have a product. So you do x to the power of 7 times 7 to the power, or sorry, x to the power of 3 times 7 to the power of 3. But that's only true for a product. That's only true when you're raising a monomial to a power. This is a binomial. And for that matter, a trinomial or any other polynomial isn't going to work like that. What this means, you have to remember what the power of 3 means. It means I'm multiplying x plus 7 by itself 3 times. I have 3 x plus 7s. So now when I actually want to expand this, what I do is pick 2 binomials to multiply together. The third one we'll leave alone. So I'll multiply these 2 together. It really doesn't matter what order it is. It's all the same polynomial. But now I'll do my double distribution. My distributing the x to the x and the x to the 7. X squared plus the 7x. And then the 7 to the x and the 7 to the 7. So that's plus 7x plus 49. Combine like terms there gives me x plus 7 times x squared plus 14x plus 49. So that's my x plus 7 times x plus 7, which incidentally is what that x plus 7 squared was. Since after all, if I'm multiplying it by itself twice, that's squaring it. But now I have a third x plus 7 to multiply in. And so I'm going to do that. X times x, x cubed. X times 14x, 14x squared. X times 49, 49x. 7 times x squared, 7x squared. 7 times 14, 7 times 14 is 98x. And 7 times 49 is 343. And now I can combine like terms. X cubed doesn't combine with anything, that's just x cubed. 14x plus 7x squared, 14x squared rather, plus 7x squared is equal to 21x squared. I have this written down, I don't want to mess it up. 21x squared. 49x plus 98x. That's 147x. And then 343 is 343. So that is my final answer there. I combined the 14x squared with the 7x squared to get 21x squared. And I combined the 49x with the 98x to get the 147x. So it's all just distribution, is just more of it. Only this is not distribution. The exponent, not distribution. But when you're multiplying a polynomial times a polynomial, it's just distribution, the same use of the distributive property, just more than once. So write it out, use space, use extra pages if you need to actually write out the x times x squared plus 14x plus 49 step, like we did with the previous example, and then the 7 times x squared plus 14x plus 49 step, to write those out separately before you distribute, if it makes more sense, if it's easier to see how that happens, how that works while you're working through it. But once you get to a certain point, you can just start doing that in your head. Kind of like we did here. I'm going to take x, I'll do x times x squared, x times 14x, x times 49 to get that.